Recording is rolling. It is Monday, September 16th. Oh, did you guys just turn in your projectile quiz? Yeah, or I see some of you guys just turned in your projectile quiz. Be grading those soon. All right, linear motion quiz. This one you guys turned in a couple weeks back. So here's the update on that. Oh, I have three different types of classes. My conceptual students, every single student's turned in the quiz at this point. So I've been able to give those back. They got the right answer circled at this point. And so those are back in, but my other classes, my honors classes, my AP classes, I'm still waiting on a few to be turned in. Hard deadline's going to have to be, well, some point. So let's put it on Wednesday. If I don't have them all by Wednesday, I'm just going to put zeros in for the ones that, because they're like 2 weeks late by this point. And everyone else who has turned it in by now, they're waiting to get them back. Right, so a little bit more on that. Here on the left side here, quiz corrections for partial credit back. I've been doing this last few years, worked pretty good. So when you guys get your quiz back in your folder, you guys see those folders hanging back there. It's where I'm returning all your work. If you missed some questions, like, hey, maybe I want some points back, here's how you can get partial credit back. There's three main types of questions I ask you guys, categories. I might ask you a graph question. If you missed a graph, just pull out a paper, a ruler, pencil, and just draw the correct graph. Right? So label the axes, variable, unit, draw the correct curve to match the story that I give you. Right? So just draw the correct graph, get partial credit back there. I usually ask you guys a few of these conceptual type questions, like straight off of Kahoot. A lot of times it's something you just write the sentence, like why does the horizontal component of velocity not change? Right? It's not really an equation, but it's just a sentence you can write out. It's okay. Most of the questions I ask you guys are this category right here, some kind of algebra-based question you could solve with an equation. So set up the correct equation, solve it, show all your steps how to get to the correct answer. Again, this is for partial credit back. The questions I ask you guys on the quiz are either exactly what we did in class or something extremely close to what we did in class. And since with the return quiz, you have the circled correct answer, I think you can figure out how to get to that. Okay? And if you're still really, really stuck, then just ask me at some point and I can help you out how to solve those, but I think you'll be able to do that. All right, so you guys good with how to get partial credit back? Right, this is, of course, have to get your quizzes back too, and everybody's got to turn it first, or you'll definitely get it back by the end of the week. All right, so all good. Okay. Right. Points here. Well, don't worry about AP if you're not AP. All right. So tomorrow we're starting a new topic. We're going to go into forces and Newton's laws of motion. So I'll show you guys a little bit about this today, so you can go home tonight, think about it, and then come back tomorrow. Okay, kind of know what's going on. Right. And then we're going to do one more kinematic motion activity today, which is going to be Flipbook animations. So I'll show you guys a little bit of this, and then you guys get to use your creativity the rest of the day. All right, so tomorrow when you guys come in, you'll get, oh, look at this pile of spring scales. Look at all these different colored spring scales. Now these are color coded, so each color corresponds to a certain spring stiffness. Here, I'm going to start with this brown one. This one's usually pretty versatile if you don't get your hands on one type color. Right? It has a medium stiffness type spring. So when I pull it with some pulling force, right? Oh, you guys know, what is a force? Is that just a push or a pull? It used to be a push or a pull. In this case, I'm pulling like a tension force. It's going to stretch it some amount. The more it stretches, the more force I had to apply to stretch it that distance. Does that make sense? Right? Now, do you guys see, here, I'm going to zoom in. It's a little closer here. But let's look at the markings here. Okay, so I see 0, 2, 4, 6, 8, 10, and the unit is capital N. Guess what do you think capital N stands for? Newtons. Okay, so that's how much force. Like here in America, we usually say how many pounds, but we're going to use metric. That's like newtons. Just how much am I pushing or pulling? In this case, pulling. Right? How many newtons? Okay. And do you guys see how it's scaled linearly? 0, 2, 4, 6, 8, 10. All the numbers are spaced out the same. What that means is this. If I apply some force, it's going to stretch some amount. Maybe apply so much force it stretches, well, actually, I know how much force I'm applying there. That's 3 newtons, and it stretched some amount. If I double that force to 6 newtons, the stretching distance also doubled to get there. Isn't that what that would mean? And we can put that all together in a graph. There's a law in physics. Here's what I'm getting to, called Hooke's law. Hooke's law. Very good. So that just says that there's a direct relationship between how much force you put on a spring and how much it stretches. Okay, so put some force, it stretches some amount. Right? Oh, do you guys think force? Oh, I was going to ask you, what does F stand for? You guys would have said force, right? Yeah, force measured in newtons. What do you think X stands for? how much you stretch the spring from its equilibrium point, right? Or it could be compression if there's a compression spring, but these are all stretchy springs. Okay? And what do you think that K stands for? If you had to guess. Huh. Right. Well, let me show you. Let me show you what that K stands for. Okay. Well, on the graph, you guys know K refers to the slope of this line. Isn't that true? The slope of this line? There's a shallow slope. There's a steep slope. There's kind of a medium slope. Huh. Right. Well, let's get back to these are all different color coded. So I was looking at the brown one. Okay, so I put some force on that stretches. Okay, I feel some give. Right. You guys think you feel that too? Right. What if I pick up the blue one? Right? Now the blue one only goes up to 2.5 newtons. The brown one went up to 10. This only goes up to 2.5. What that means is I put a tiny force. Whoa, that stretches real easy. Look at that. Hardly any force at all. That's really easy to stretch that one. What about this gold one? This gold one goes up to 50 newtons. Ooh, so I'd have to apply 50 newtons just to stretch it this distance? What does that feel like? I'm applying so much force. So much force. It's really hard to stretch it. A huge force and it hardly stretches at all. That's it. Okay, so if I go back to this Hooke's law graph, how does that apply to Hooke's law? Well, that means this. With the brown one, I start with the brown one. I applied some force, it stretched some amount, or stretched some amount of corresponds to some pulling force. Okay, so I can be like right there. Okay, let's throw that on the board. Boom. Now the blue one, you guys remember that's like this little leaky spring. Hardly any force at all. It stretches right away. That could be like a point way over here. Hey, that's like a shallow slope, isn't it? On that graph, a shallow slope. And then there was the gold one. That's why I pull a huge force. So hard to stretch it. So a huge force, it hardly stretches at all. Wouldn't that be like a really steep graph on that? It's a steep slope. Isn't that true? Right. So I'm here. I've got these spring scales laid out as if they're lines on that graph. Right. Got a shallow slope, a medium slope, and a steep slope. Right. Okay, that's what this K is. It's telling you how stiff the spring is. It's called spring constant or spring stiffness. You'll see both those terms: spring constant, spring stiffness. All right. So you guys see that too? Another detail about Hooke's law: a lot of textbooks throw a negative sign here. If you go to college and your college instructor writes F equals negative KX, they're referring to not the applied force, but the restoring force. So here, if you stretch it out by some amount, the spring pulls back the opposite direction. So I usually just ignore the negative sign, but sometimes you see that too. All right. So you guys good on Hooke's law so far? All right. So what's the application tomorrow? I'm going to give you guys a pile of spring scales, and I'm going to have you guys do 10 mini labs. 10 mini labs. Let's look through them real fast so that when you guys show up tomorrow, like, oh yeah, I remember what's going on. All right, so first one, what if you have a spring scale and you hang different weights? Right, so you have small weights, big weights. Do you think you can make a graph, right? The hanging mass versus the force. I wonder what that would look like. Hey, what if you have two spring scales hanging one weight? And what if you shift them around a little bit? You guys ever done this? You guys ever stood on two legs? You shift your weight over to more to the right leg and then more to the left leg, right? Now that's more compression. This right here is more like tension, but it's some kind of force. Ooh, I wonder what that look like. What's the left scale rating versus the right scale rating for like the same weight over and over, but you kind of shift them back and forth, right? Let's take this to 2 dimensions. Right? What if you hold it all vertical, right? So we got spring scale, spring scale, spring scale, and then you start to stretch it out, make like a Y shape. And then you stretch it out more, and then you stretch it out more, and now it's getting closer and closer to a T shape. What do you think is happening to the readings in each one of these scales as it goes from vertical to Y to spread out Y to more of a T? Right, of course, you're going to see tomorrow, but maybe you can do a little quick hypothesis right now. When you think about it. The chain gang. What if you have, hey, is this like barrel of monkeys? Scale, weight, scale, weight, scale, weight. If you were a monkey in a barrel of monkeys, you want to be a monkey near the top of the chain or a monkey near the bottom of the chain? What does that mean for the physics of what do you think these scale readings are going to read? Hey, what if you slip in another scale right here? Or if I have like a double scale in the middle? What do you think those force readings happens? What if you had a monkey and a monkey friend? On the back, let's make this dynamic. Let's give some motion to this. What if you accelerate this up and down? It's been in an elevator, the floor starts moving, like, whoa, the floor's moving. Which way does this accelerate? What does that do to the scale rate? What if you connect 2 spring scales by a string and you accelerate one back and forth? What happens to the force ratings in those scales? Hey, Hey, what if you lift weight versus drag it across the table? And we'll do a more extensive version of this coming up too. Okay, but be quicker, huh? How does force readings compare? Huh? Okay, so that's the main ones I want you guys to do. Okay, so a bunch of mini labs. You guys get to investigate forces and with spring scales tomorrow. Okay, so you guys okay with that so far? Okay, so I need to run a bunch of copies of that lab page, and that'll be that. All right. So main activity though today is let's get to these flip books. So you guys get to use your imagination today and apply all your physics knowledge to make an animation. If you want to make a good animation, you got to know frame by frame where does every object go. Right, so here I'll show you guys a bunch of examples from past year. Cat and a ball. Ooh, did you guys see a couple of parabola type motion? Okay. If you want to make that realistic, got to get frame by frame. Okay, where's the ball go? Where's the cat go? We got, let's see what was this one. All right. Oh, it's a UFO flying around. Whoa. All right, that escalated quickly. How about guy with bow? Boing. Oh, look at that nice projectile. The end. So at the end, let's do how about this guy on a trampoline? Boing. Boing. Pretty good. How about let's oh yeah, so much. Yeah. Oh, fireworks. That's pretty good. Fireworks. Ooh. Fireworks. Stay surfing. I'm surfing, swimming. All right. Here's a good finale right here. Showstopper, Blue Shark. Yep, it's definitely the end. The end. So you guys use your imagination, come up with a good flip book. Oh, I need to show you guys how to cut this. Okay, so you might have a flip book that you can already flip. If you do, then you're ready to go. Draw your frame, or you might have one that looks like this. Doesn't flip. So I'll show you guys what to do with this. Okay, if it's folded over the edge. Okay, so guys, just follow this. You guys see the binding on the left, the two staples binding? I'm gonna roll twice. So roll once, roll twice, then flatten that out. Okay. If you're up to that step, just freeze right there. So just hang tight. If you missed it, I'm gonna rewind a little bit. Okay, so I had a book look like this. I'm gonna take that binding on the left, those two staples, go roll once, roll twice, then flatten this out. So I've rolled it a couple of times. It's that. So you have to roll it a couple of times, otherwise it's not gonna work too well. Okay. Then you guys got some heavy duty scissors. I'm gonna shave off about, let's say almost a centimeter on the right side. Oh, there's a trash bin in the middle of the room. You guys got, so there you go. So just pop off almost a centimeter there. Then unroll, and oh, look at what I got now. Flip book, ready to go. All right, so hey, you guys said use your imagination. If you need some coloring items, you got color pencils, markers, crayons in the middle of the room. I'll walk around, check your work. If you want to share it with the room, I can throw in the projection up here. And if you guys have any questions, otherwise, let me know.